talk, I will start with a bit of a personal story regarding my talk. Because I worked on this stuff that I'll be showing you today. I started working on this at the end of June, which is when I looked like this. Because I was 9 months pregnant, sitting at home, on maternity leave already, and very, very bored. Because the baby was supposed to be born any moment, and I was just sitting at home doing nothing. So I was doing what any person in my position would be doing. That means reading the internet. And I came across this blog post. Developers who use spaces make more money than those who use tabs. That's weird, right? Like what the sort of indentation you use has to do with your salary. And then this thing spread over the internet. Oh, the main thing in this blog was this plot that says the salary for developers who use tabs and spaces. This is the number of years someone was working as a developer. And on the y-axis is the median annual salary. And in red is the salary for people who use spaces. And the other two lines are for people who use tabs and who makes both tabs and spaces. So this is weird. There's a really large gap. And people who use spaces have much larger salary than the others. And this took over the internet for a couple of days, maybe. So you got articles in normal newspapers saying programmers who use spaces in their code get paid more than those who use tabs. And even BBC News, who should know better, published programmers who use spaces are paid more. So right now, my reaction was, correlation is not causation. And I was very frustrated at home, and I thought, okay, someone is wrong on the internet, and I have to do something about it. Because someone is wrong on the internet. Well, this was actually the reaction of most of the people on the internet, because everyone knows that. Everyone is taught that in their introductory statistics class. So everyone knows this as a sort of mantra. Correlation doesn't mean causation. It's not the same thing. But it doesn't really tell us anything about the data. So why do developers who use spaces have larger salaries than the others? This doesn't say anything. So can we go a bit deeper and actually look why do some developers have larger salary than others, and what does it have to do with the indentation? So first, a little bit about correlation and causation. Correlation is just an association. So for example, when it snows and it's winter, you know that it probably snows because it's the winter. So that's sort of a causal relation. I don't know how much it snows here. In the UK, it never snows, so I wouldn't know that causation relation anyway. So correlation is just an association. Two things appear together, and one of them doesn't influence the other in any way. So for example, as a developer, if I look at this survey and I say, okay, I should use spaces and I will get paid more. It doesn't work like that. Or as an employer, I can say, okay, so now our code standard will be to use tabs, and I will give you less money. Well, it doesn't work like that anyway. So correlation is not causation. And my favorite example of that, well, the thing is everyone loves a nice correlation, and the news are a prime example of that. So I did some random Googling to look at some articles. And for example, too much exercise can kill you, especially if you are a white man. So who exercises? Well, it might kill you. Chocolate may help keep people slim. That's the sort of causal relation that the news have inferred from some kind of study. So if you are fat, you want to get slim, eat chocolate. Doesn't work like that. But the newspapers love that. Why going to university increases risk of getting a brain tumor? So eat chocolate, don't exercise, and don't go to university. And happiness is a plate full of vegetables. Study finds eating your greens can help improve your outlook on life. So next time you are feeling low because you are using tabs and you are paid less, eat your vegetables. So while you are eating your vegetables, the first thing to remember is never try to use causal language for correlation data, which is something that the news do all the time. They see some kind of association in a study and they say, okay, programmers who use spaces get paid more. it sort of implies a causal relation. So it's very hard to talk about this sort of data and keep the language neutral. So a bit more sort of less causal way to say this would be spaces are associated with larger salary. That doesn't imply any direction in the correlation. So yeah, don't use causal language. And whenever you are looking at something like that and you see some correlation or some study like that, first thing to check is it really a correlation or a causation? And the only foolproof way to get a causal relation from data is to conduct a randomized study, where you take your subjects, randomize them, and then the only variable that will be different is the one that you are trying to examine. So in our example with spaces and tabs would be to take a lot of young kids, probably, who haven't programmed before, teach them how to program and teach them only to use spaces or only to use tabs, and then see in 10, 20 years, do they have larger salary or not? Obviously, we can't do that. So we can only look at the data and try to infer something from there. There are some statistical ways to try to infer causation from data, but they are not very reliable. And they mostly just infer correlation structure from the data, like a correlation graph, which feature influences which feature. And whenever you have some studies like this, the main problem there is usually that they have a very small sample size. If they conduct a study on 20 people, then anything can come out of that. So always check for small sample size. And sometimes you get some results only by chance. And if you repeat a survey or study, the results are lost. And sometimes the main cause of the correlation is some hidden latent variable. I will talk about it a bit more. And I will show it on an example. So I don't know if it's in Italy as well, but the thing when a little baby comes to you and says, so how are babies made? And you say, oh, storks bring babies. This actually originates from Germany, and the sort of idea behind that originally is that more babies are born in the spring, which is when the storks come. So storks are bringing babies. But I am a statistician. So if I see a theory, okay, storks deliver babies, I will do a statistical test, right? And there are data on birth rate in countries and how many stork breeding pairs are in each country. So let's plot that. So this tells us the number of breeding pairs on the x-axis and the birth rate in a country on the y-axis. And this is my regression line. And actually, the correlation coefficient is 0.62, which means there is a correlation between birth rate and the number of storks in a country. And the p-value, which tells me what is the probability that I would get this sort of correlation by chance, is 0.008, which means it's less than 1% probability, 0.8% probability that I would get this by chance. So, like this, I can't reject the hypothesis that storks bring babies, because the data tell me that, yeah, there is an association. So what's happening there? So do storks bring babies? Well, I haven't actually seen any stork bring a baby. So I assume there is some hidden variable that influences both the number of storks in a country and the number of children that are being born in a country. Can anyone guess what kind of latent variable size? That's the right answer, actually. So this is another plot showing the number of storks and the area of a country. And you can see that there is another correlation. And even stronger association is the birth rate and the area of a country. So yes, actually the area or the size of a country influences both the number of storks that are there, because it's physically larger, there are more storks, and the number of babies, because more people live in the country. So that's the latent variable. I like this example because it's not so obvious immediately. Because in introductory statistics classes usually talk about things like children's ability to read and their shoe size. They're also very much correlated, but they are both influenced by the age. So what's our latent variable in case of the tabs and spaces? This is a bit more difficult because there is nothing as obvious as the country area we had before. So first thing I did was I looked at the original blog post, and they were modeling the salary using linear regression using several predictors. Things like the country where programmer is, years of programming experience, whether they use tabs or spaces, what developer type they are and what language they use, what kind of level of formal education they have, whether they contribute to open source, whether they program as a hobby, and their company size, which are all the things that would sort of intuitively influence their salary. And from this, they concluded that the tabs and spaces are very important because the linear regression told them so. Because in linear regression, you can look at importance of each variable there. So I thought, okay, so let's examine it a bit further. What happens how can we predict a salary if we remove the tabs and spaces? Do they actually add any useful information to the linear regression? So, sorry, there'll be a little bit of statistics. So I know it's after lunch, but what I can do with linear regression, I can construct two related models. One, which will include all the variables, which will tell me, okay, this is how well I can predict salary if I include all the variables that I mentioned before. And then I can create another smaller model that will just have all the same variables excluding the tabs and spaces. And this is a statistically valid method to compare how good each model is, or how well they compare to each other. So what I get out of this is something called the coefficient of determination. And that's a value that tells me how much variance in salary does my model explain. So if my model can explain 100% of variation in a salary, that means I have perfect prediction. If it can explain only 10% of the variance in salary, then I have completely rubbish prediction. And actually, both of these models could explain about 40% of the salary variation between people. So they don't capture that much information, but almost half of the variation I can get. And if I look at the coefficient of determination, the larger the better. So the full model has slightly larger than the reduced model without the tabs and spaces. But this is expected because if you add more information to a model, the fit will be always better. So what you are supposed to look at here is called the adjusted coefficient of determination, which is basically the same for both models. This is rounded to 4 decimal spaces, and it's the same number. So they give me exactly the same fit, even if I don't give it the information about tabs and spaces. So if someone uses tabs and spaces, it doesn't actually give me any useful information to predict their salary. So first example, why that title, oh, developers who use spaces are paid more, is not really telling me anything. So first thing I wanted to check is collinearity, which is something, if you are fitting a linear model and two variables that are in the model are correlated, then you can include just one of them, and the other is redundant because it doesn't give you any additional information. That's called collinearity. So if there is some other information in the model that gives me the same information as tabs and spaces, for example, the language that people use, then I know, okay, these things are the same, and it's actually the language that influences the salary. So I checked it. You can check it by fitting two models and checking if the coefficients that the model gives you are very different. They were not. So there wasn't any obvious collinearity. So what gave me the performance in the reduced model was a combination of some other factors. So I checked which things got more important for the model in the reduced case. So what changed in the reduced model? And actually the things that got very different, that got more significant, were years of programming experience, that very obviously influences salary. Contributing to open source. Now this is interesting. And the third thing that changed importance was PHP. Okay, so I guess PHP influences your salary as well. But I got interested in contributing in open source, because that's something that wasn't that important in the original model and got more important now. So, open source. I think we would all love to have this sort of idea that if you contribute to open source, your salary will be larger. So let's verify that. So this is actually a plot showing, again, number of years someone coded and their annual salary. And the blue curve is they don't contribute to open source, and the orange one is they contribute to open source. So yes, contributors to open source have larger salaries on average, which is good news. So please contribute to open source. And if you do contribute to open source and are thinking, so where is my salary? Listen more. So I also checked if open source contributors use tabs or spaces. And this is if someone contributes to open source, and if they don't, they use spaces and tabs almost in the same way. The green one is they use both. And if they do contribute to open source, people use spaces much more than tabs. Now, this is interesting. So spaces are more common in open source than they are in closed source, let's say. And this is for US developers, and almost the same thing works also for international developers. So people who don't contribute to open source use tabs even more than spaces. So what's happening there? Do we have some kind of potential explanation now? Because people who are doing open source are paid more, and they use tabs less than people who don't contribute to open source. And the thing is, with tabs, it very much depends on how your IDE is set up, the way they are displayed in your code. So if you have a lot of tabs there, and you give your code to a colleague, and you have the setup that each tab corresponds to 4 spaces. Then your colleague who has different setup, like 2 spaces. Then the code will look completely different, especially if you mix tabs and spaces. So it makes sense that if you want to share your code, you will use spaces, and it will be consistent between different people and different editors. So that's one kind of explanation, or my hypothesis. And another thing is, there might be some language effect as well. So, for example, this is for C#, and C# doesn't have such a big open source community as some other languages. And you can see that people who use C# use tabs more than spaces. And this is example for Python. Well, these are not just people who do Python, because in Python it doesn't make any sense to use tabs. These are people who have in previous year predominantly used or extensively used Python or used C#. But in Python, quite logically, the spaces are much more common than tabs. So there is also some language effect where different languages have very different usage of tabs and spaces traditionally. So there is also an association with languages and open source, where some languages are more common in open source than others. So how does it fit together with the salary? Because so far I was talking just about using tabs and spaces and open source, etc. So I will make this plot a bit larger. So now, it's not getting bigger. All right. So now the blue line in the top are people who use spaces and do contribute to open source. And they still have the largest salary among all the others. But now, if you are a senior programmer and use tabs and contribute to open source, you have basically the same salary as people who use spaces. So this slightly breaks down the relation between just tabs and spaces and salary. Now there is the contribution of open source. But still, if you look at the overall effect, people who use spaces are still paid, on average, more than people who use tabs. So I decided to look at something different. Because in the linear regression, I think there wasn't that much to see anymore. So I looked at salary distribution for junior developers, for example. And you can see these are density plots. And people who use tabs and spaces and mix both, most of them have their salary around the same value, which in this case, it's around $70,000 annually or among US developers. But for people who use spaces, there is the sort of shoulder there. It's called that the distribution is bimodal. It has two modes, one there and the other there, which means there is a group of people who use spaces and are paid significantly more than people who use tabs or mix both. So who are those people? I suppose everyone wants to be in that shoulder there, right? So, more statistical testing. So I basically tested what makes these people different. And this is a bit of p-hacking, because you are testing a lot of things and trying to get something interesting out of that. But the thing that jumped up was the version control use. So people who use Git, they are more common among the people who have higher salary than the people who have lower salary. And people who use Subversion or TFS, Team Foundation Server, they are more common among the lower salary group. So if you use TFS or Subversion at work, convince your boss to use Git. It doesn't work like that anyway. But the difference, the p-value, this is an output from R, is significantly different. So yay, I have significant difference. So people who use Git have higher salary. So most of the people in this shoulder use Git as a version control. So this is my theory. So does version control contribute for the difference? Well, this is my updated plot, where I plotted the version control people use and if they use TFS or Git. And you can see that people who use Git have higher salary than people who use TFS. And the same works for the tabs and spaces. Sorry. If you use... Now, if you look at the dark blue line and the dark orange line, in this one, if people use spaces with Git, they are paid higher. And people who use tabs with Git, which is the orange line, they are paid more than the others as well. So this finally breaks the relation between people who use spaces are always paid more. So people who use tabs and Git are paid more than the others. So why is that? That doesn't make any sense, right? If you switch to Git, do you get paid more? Yeah, and another thing I wanted to show you, if you use spaces with Git, you get paid much more than if you use spaces with TFS. Interesting, right? And the same, or almost the same, holds internationally. I will skip this. I will give you a link so you can look at the plots yourself afterwards. And the same works for Git and Subversion. So if you use Git, you get paid more whether you use tabs or spaces or not. So why is version control so important? It's, again, not something that you can change and it changes your salary completely. So I think if we put it together with open source and sort of language effect, together they give you the sort of environment in which you work and the type of company where you work. Because some companies that are a bit more traditional, they might be using TFS and some traditional languages. And other companies are using open source, are a bit more open, are a bit more cool, so they want to attract people, or startups. They basically throw money at people, so they get paid more. And these people usually use Git. So my theory is that it's the more sort of the company type where people work that influences whether they use or contribute to open source, what sort of version control system they use. And this can't be captured by one single variable. So it's sort of thing that jumps up as a big picture out of these little things. So I wanted to show you. You can go to my GitHub, actually, and you can play with the talk. Sorry. And what you will get is actually my R code where all the things that I was showing you are basically generated. This is my talk. These are my slides, actually. You can see that they don't really look like slides very much, but they generate all the plots. And you can change them and play with them. So I wanted to show you some plot. For example, let's look at the language effect. And now if I decide I'm more interested in JavaScript, I will just change this, and I can run it. And, oh, it's probably, I don't know, sometimes, yeah. So in JavaScript, people use tabs and spaces about the same way. So you can actually run things and generate your own slides. So this is all on my GitHub, if you go there. But I wanted to mention one more thing. Can we actually trust the data? Because these data come from Stack Overflow developer survey, which they do annually, and they basically just ask people on the internet to fill in a survey. And that's not a very reliable way to collect data, because people who actually answer the survey, they are self-selected. They want to fill in the survey. And I had some suspicions about the data. I looked at the salary, and this is a histogram showing the salary distribution. And you can see that most people are paid around $50,000, but there is a strange peak here at the beginning. And this is annual salary. So I looked at countries where people report their annual salary lower than $3,000. Annual salary, $3,000. That's not much, right? So most of them are in India. So I thought, okay, that's sort of understandable. India is not a very rich country. But then the second one is Poland. That's a normal European country. I don't think developers in Poland are paid less than $3,000 per year. Then Russia, and Brazil, Romania, Pakistan, Ukraine, and Germany. Among the top 10 countries where developers report their annual salary lower than $3,000 is Germany. I thought, okay, something stinks here. This is really strange. So I looked at the salary distribution. And this is a salary distribution for France, India, and the United Kingdom. And you can see that it looks more or less normal. There is just one peak, and it's sort of distributed. But if I look at Germany, Poland, and Russia, the distribution looks very different, right? There is a strong peak in the beginning, which are the people who are paid $3,000 per year. And then there is a larger hump later. And the hump is in different positions. So in Germany, people are generally paid more than in Poland. That's something I would expect. But I wouldn't expect this hump in the beginning. And because I'm Czech originally, so I have some domain knowledge. I know that people in Czech Republic, they never talk about their annual salary. I don't know how it works in Italy, but we never talk about annual salary. If you are negotiating a position, you always talk about monthly salary. So I thought, okay, so what happened there? Actually, this is how the question looked in the questionnaire. So what's your current annual salary, annual underlined? Please enter whole number, blah, blah, blah. I thought, okay, people are filling in some survey on the internet. They don't read the question properly. Maybe they are reporting their monthly salary, actually. So this is how it looked for Poland. So I decided to basically take these people who are reporting suspiciously low salary in the beginning and multiply it by 12. And this is a new distribution of salaries in Poland that I got. Now this looks much more like it, right? So we can't really trust the salary data anyway, because quite a lot of people from different countries are reporting their monthly salary simply because they don't read. And if I look at how many people actually filled in the survey, well, quite a lot of people filled in the survey, but most people didn't fill in their salary. And now, if you are a statistician, or more, if you are a sociologist or someone like that, you know that there is something happening there as well. Because there are several different types of missing data in statistics. Data might be missing completely at random. This almost never happens. This means that the data that are missing have nothing to do with the actual method of getting the data and the survey and the questions. This basically corresponds to someone going with some surveys somewhere and then losing half of them. That's missing data completely at random. Another type of missing data is missing at random. And this is already not missing randomly, not something that we would consider missing randomly. Because the way the data are missing when they are missing at random is that the way you can actually predict which data will be missing from the rest of the data you have. So for me, I would be able to predict, for example, if people who live in Russia, they don't want to say what their salary is, then that's connected, and I can predict if they will tell me their salary or not. So the data would be missing at random. This is most common. Or data might be missing not at random, and this is really hard, because that means that the data that are missing are something to do with the question you are asking. And one example is that people who have high salary, like very high salary, they usually don't tell you that. And this basically depends on the question you are asking. So I will ask you, what's your salary? You say, I prefer not to say that. You have either very high salary or very low salary. Because people who have very high, they just don't want to say that. And if they have very low salary, people are ashamed. That's a very normal, genuine reaction. So I think I looked at the data. I couldn't get something like very specific out of that. But my suspicion is that some of the data that are missing at random. That means I can predict which data are missing. Also, it can be, for example, that the question about salary was one of the last questions in the survey. So people simply get bored and they don't fill it in. But the question of missing not at random, that's the most difficult to actually infer. And the data you can have problems with are, they can be missing accidentally or deliberately. And this happens in real life as well. For example, the vote predictions before US presidential elections gave Trump much smaller chance of winning. And one theory is that people were simply ashamed to tell the surveyors that they will vote for Trump. And this is a very normal reaction. For example, if someone is doing a survey on the street and they ask you, okay, do you beat your children? Even if you were, you wouldn't say that probably, because it's talking to someone and admitting something really embarrassing. So there are a lot of problems with data, and when the data are missing, they can be missing either accidentally or deliberately, and sometimes they are just wrong, like the salary data. So if I input the data into some sort of model, they will give me completely wrong results. So what can we do with the data? Can we actually trust anything? Can we trust the data? The problem right now is that a lot of people are using all sorts of machine learning as a service techniques or methods. And if you are using something like that, you just put in your data, it works as a black box, it gives you some kind of result. And if you don't check the data, then you might get into all sorts of troubles. Because this thing with tabs and spaces and salary, that's very obvious that it's not a causal relation. But if you are working with some more complex data that you don't understand that well, then you might think, okay, so let's get everyone paid more, let's force them to use just spaces. And these sorts of interventions, they happen in real life. And because right now they are using machine learning prediction methods for policing, for targeting areas that have more crime than others, etc. And if they pick the wrong intervention, then it can lead to all sorts of strange results. And so don't treat models as black box, because it always depends on the interpretation, and you always have to check the data. Because sometimes they are just plainly wrong, sometimes they are misleading, sometimes they are missing, and it's not that you can ignore all the missing data. And it all depends on how you interpret it. So I will end my personal story with this because I wrote it up in a blog post that you can look up on my blog. And it got to the top of Hacker News, and 3 days later I gave birth to my baby. So this was a very demanding week for me. And at least digging into this sort of problem took my mind off things, which was very good. So if you want a consulting data detective, contact me on Twitter. And you can read my blog here. And there's also a link to my GitHub where you can get all the code and all the data, and you can play with them yourself. Okay, thank you.